after this testing, then, this logic stick is ready for the computer.
Well, no, there's one more stage, John, and that's the potting of the module.
What do you mean by potting?
Well, the potting is this plastic coating that provides a covering for the wiring and the components. Now the module is ready to be plugged into the logic tray assembly.
That's number 38, and there are all these other modules, too, that might be a little different.
That's right.
But what about the memory modules?
So the memory modules of the computer are made using a basic component, which is a donut-shaped magnetic core. Now, this core will be placed into a component holder like so. Now, after the component holder has been completely loaded with cores, we're then ready to do the wiring. In order to perform the wiring operation, we store about 20 feet of wire in this needle. See how that wire comes out of there? Now, the operator will take a core holder and pass the needle through the core, around to the other side, and then weave it back through to different positions. Now, let's watch how the girls do this operation in a little more detail. Now, here we have a pair of girls who are wiring the address wiring of the core rope module. Now, they pass the wire back and forth, stored in the needle, and put it through the cores in a particular wiring pattern. Now, each time a wire goes through, they must very carefully wrap the wire around one of those little nylon pins. As you can see, what that does is pull the wire away from the center of the core to allow room to pass the needle through again.
I see. Now, these address wires go to every single core?
That's right. Now, when the wire is completely weaved into the rope, it must be terminated on a little solder terminal. Now, the girl strips the insulation from the wire and very carefully wraps it around the pin. Then they use a magnifying glass to inspect their work. Now, the sense wiring information, or the wiring that contains the program of the fixed memory, is performed by using this machine. The machine indexes to a particular location of a core, and then the girl passes the needle through the aperture and provides the wire to go through the right core.
She doesn't have to think about which core it goes through next.
No, the machine does that for her. Now note, each time the wire passes through, that little aperture jogs down and pulls the wire around one of the nylon pins. When she passes the needle through, she will trip the switch with the needle, which causes a tape reader to advance. There's the tape reader, and that in turn causes the core rope plane to move its position. Now, after all the wiring is completed, these nylon pins that we use to temporarily hold the wire can now be removed. Next, we must press the wires very gently down into place so we'll be able to fold up the whole assembly. Now, this operator is folding the core planes into a sandwich-type construction and laying them into the header of the module. Now we're ready for electrical test. We must ensure that every wire and every component are properly located. The operator puts the module into this piece of special test equipment, and a program stored on paper tape is then used to exercise the module.
But this is certainly a complicated-looking maze of wiring in here.
That certainly is, John. That module contains 512 cores and over a half a mile of wire. And it performs the function of storing over 65,000 individual pieces of information.
I mean, you put that potting compound all over this, too?
Yes. Now, in the final form, here's the module potted, and it's all ready to be plugged into the memory tray assembly.
I mean, how do you connect one module to the next one in these trays?
Well, that's done on the back side of the tray. Let me show you.
Oh, I see.
Now, here you see a fairly complex wiring pattern. And we're able to interconnect from module to module by running wires from this pin to, say, that pin.
Right.
Now, this pattern is so complex that we've used a computer program to determine the exact layout of each wire. That is, we may run a wire from here to here by going down this way and over here and up there.
Why is that?
Well, that's to avoid a density problem where the wires could build up if we laid them all in the same channel.
Oh, I see. But I should think that'd make it rather hard for somebody who was trying to wire from one pin to another to remember all that.
That's true. In fact, the wiring is so complex that a human being just can't do it. So we use a machine to do all of this wiring. This is the automatic wire wrap machine. The operator has placed the tray in the machine and is starting the wiring operation. Now this machine has two wire wrap tools that can be incremented to the proper location on the tray. When it's found the right pins, the wire is stretched out and formed in the right pattern. Then the insulation is stripped from the ends of the wires, and finally the two tools drop down and wrap two pins simultaneously. Now, in order
around corners and things?
Yes, you can. And in order to run the wire in a different direction, sometimes the tray is rotated. It can be positioned in 4 different locations. Now, the information to command those wire wrap tools is contained on these IBM cards. Each card has the information for a single wire.
How is the wire actually fastened to the pin? Is it soldered or welded?
No, this is what's known as a wire wrap connection. The soft copper wire is very tightly wrapped around the pin, and you might see that the pin is a square-cornered pin. And in this fashion, the wire digs into the sharp corners of the pin and provides a good electrical connection. Now we're entering the computer system test area, John. After the trays have been potted and the modules assembled to the trays, we bring the machine into this area and run through exhaustive temperature tests and vibration tests.
I see.
Then finally, we must perform a complete electrical checkout of the computer. Now this piece of equipment is the computer test set. This provides a means to enter data into the machine and monitor all of the various outputs. Here we have a piece of equipment that provides the power and interconnects the computer to the 2 display and keyboards.
Now, what kind of tests would you perform on it?
Well, actually, we've written a very special fixed memory program that allows the machine to test itself. As an example, we can have the machine test that all of the possible displays can be created. Let me show you. Now, as I enter that, we see that the displays go from all 9s to all 8s and so forth down the line.
Now, is this the last time that the computer is tested before it actually is flown?
No. The computer will be tested several times as part of the guidance and navigation system. In fact, the same type of equipment that we have here will be used for these various tests.
Thank you very much, Mr. Fountain. Today, we visited the instrumentation laboratory at MIT and the Raytheon Company in Waltham, Massachusetts. I'm John Fitch, MIT science reporter.